Section 3 of Tractatus Logico Philosophicus. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. Tractatus Logico Philosophicus by Ludwig Wittgenstein. Translated by C. K. Ogden. Section 3. 5. Propositions are truth functions of elementary propositions. Bracket, an elementary proposition is a truth function of itself. Close bracket. 5.01. The elementary propositions are the truth arguments of propositions. 5.02. It is natural to confuse the arguments of functions with the indices of names. For I recognize the meaning of the sign containing it from the argument just as much as from the index. In Russell's plus subscript C, for example, C is an index which indicates that the whole sign is the addition sign for cardinal numbers. But this way of symbolizing depends on arbitrary agreement, and could choose a simple sign instead of plus subscript C. But in not symbol P, P is not an index, but an argument. The sense of not symbol P, cannot be understood unless the sense of P has previously been understood. Bracket. In the name Julius Caesar, Julius is an index. The index is always part of a description of the object to whose name we attach it. For example, the Caesar of the Julian gens. Close bracket. The confusion of argument and index is, if I am not mistaken, at the root of Frege's theory of the meaning of propositions and functions. For Frege, the propositions of logic were names, and their arguments the indices of these names. 5.1. The truth functions can be ordered in series. That is the foundation of the theory of probability. 5.101. The truth functions of every number of elementary propositions can be written in a scheme of the following kind. Bracket, T, 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 close bracket, bracket, P, comma, Q, close bracket. Tautology, bracket, if P, then P, and if Q, then Q, close bracket. Square bracket, P implies symbol P, and symbol Q implies symbol Q, close square bracket. Bracket, F, T, 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 close bracket. Bracket, P, comma, Q, close bracket. In words, not both P and Q. Square bracket, not symbol, bracket, P and symbol Q, close bracket, close square bracket. Bracket, T, F, T, T, close bracket, bracket, P, comma, Q, close bracket. If Q, then P, square bracket, Q implies symbol P, close square bracket. Bracket, T, T, F, T, close bracket, bracket, P, comma, Q, close bracket. If P, then Q, square bracket, P implies symbol Q, close square bracket. Bracket, T, 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 F, close bracket, bracket, P, comma, Q, close bracket. P or Q, square bracket, P or symbol Q, close square bracket. bracket, F, F, T, T, close bracket, bracket, P, comma, Q, close bracket, not Q, square bracket, not symbol, Q, close square bracket, bracket, F, T, F, T, close bracket, bracket, P, comma, Q, close bracket, not P, square bracket, not symbol, P, close square bracket, bracket, F, T, T, F, close bracket, bracket, P, comma, Q, close bracket, P or Q, but not both, square bracket, P and symbol, not symbol, Q, colon, or symbol, colon, Q and symbol, not symbol, P, close square bracket, bracket, T, F, F, T, close bracket, bracket, P, comma, Q, close bracket, if P, then Q, and if Q, then P, square bracket, P, if and only if symbol, Q, close square bracket, bracket, T, F, T, F, close bracket, bracket, P, comma, Q, close bracket, P, bracket, T, T, F, F, close bracket, bracket, P, comma, Q, close bracket, Q, bracket, F, 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 T, close bracket, bracket, P, comma, Q, close bracket, neither P nor Q, square bracket, P and symbol, not symbol, Q, or P, neither nor symbol, Q, close square bracket, bracket, F, F, T, F, close bracket, bracket, P, comma, Q, close bracket, P and not Q, square bracket, P and symbol, not symbol, Q, close square bracket, bracket, F, T, F, F, close bracket, bracket, P, comma, Q, close bracket, Q and not P, square bracket, Q and symbol, not symbol, P, close square bracket, bracket, T, F, 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 close bracket, bracket, P, comma, Q, close bracket, P and Q, square bracket, P and symbol, Q, close square bracket, bracket, F, 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 close bracket, bracket, P, comma, Q, close bracket, contradiction, bracket, P and not P, and Q and not Q, close bracket, square bracket, P and symbol, not symbol, P, and symbol, Q, and symbol, not symbol, Q, close square bracket. Those truth possibilities of its truth arguments, which verify the proposition, I shall call its truth grounds. 5.11. If the truth grounds which are common to a number of propositions are all also truth grounds of some one proposition, we say that the truth of this proposition follows from the truth of those propositions. 5.12. In particular, the truth of a proposition P follows from that of a proposition Q, if all the truth grounds of the second are truth grounds of the first. 5.121. The truth grounds of Q are contained in those of P. P follows from Q. 5.122. If P follows from Q, the sense of P is contained in that of Q. 5.123. If a God creates a world in which certain propositions are true, he creates thereby also a world in which all propositions consequent on them are true. And similarly, he could not create a world in which the proposition P is true without creating all its objects. 5.124. A proposition asserts every proposition which follows from it. 5.1241. P end symbol Q is one of the propositions which assert P, and at the same time one of the propositions which assert Q. Two propositions are opposed to one another if there is no significant proposition which asserts them both. Every proposition which contradicts another denies it. 5.13. That the truth of one proposition follows from the truth of other propositions, we perceive from the structure of the propositions. 5.131. If the truth of one proposition follows from the truth of others, this expresses itself in relations in which the forms of these propositions stand to one another, and we do not need to put them in these relations first by connecting them with one another in a proposition, for these relations are internal, and exist as soon as, and by the very fact that, the propositions exist. 5.1311. When we conclude from P or symbol Q and not symbol P to Q, the relation between the forms of the propositions P or symbol Q and not symbol P is here concealed by the method of symbolizing. But if we write, for example, instead of P or symbol Q P neither nor symbol Q and symbol neither nor symbol and symbol P neither nor symbol Q and instead of not symbol P P neither nor symbol P bracket P neither nor symbol Q equals neither P nor Q close bracket, then the interconnection becomes obvious. Bracket. The fact that we can infer FA from bracket X close bracket and symbol Fx shows that generality is present also in the symbol bracket X close bracket and symbol Fx close bracket. 5.132. If P follows from Q, I can conclude from Q to P, infer P from Q. The method of inference is to be understood from the two propositions alone. Only they themselves can justify the inference. Laws of inference, which, as in Frege and Russell, are to justify the conclusions, are senseless and would be superfluous. 5.133. All inference takes place a priori. 5.134. From an elementary proposition, no other can be inferred. 5.135. In no way can an inference be made from the existence of one state of affairs to the existence of another entirely different from it. 5.136. There is no causal nexus which justifies such an inference. 5.1361. The events of the future cannot be inferred from those of the present. Superstition is the belief in the causal nexus. 5.1362. The freedom of the will consists in the fact that future actions cannot be known now. We could only know them if causality were an inner necessity, like that of logical deduction. The connection of knowledge and what is known is that of logical necessity. A knows that P is the case, is senseless if P is a tautology. 5.1363. If from the fact that a proposition is obvious to us, it does not follow that it is true, then obviousness is no justification for our belief in its truth. 5.14. If a proposition follows from another, then the latter says more than the former less than the latter. 5.141. If P follows from Q, and Q from P, then they are one and the same proposition. 5.142. A tautology follows from all propositions. It says nothing. 5.143. Contradiction is something shared by propositions, which no proposition has in common with another. Tautology is that which is shared by all propositions, which have nothing in common with one another. Contradiction vanishes, so to speak, outside. Tautology inside all propositions. Contradiction is the eternal limit of the propositions. Tautology their substanceless center. 5.15. If T subscript R is the number of the truth grounds of the proposition R, T subscript RS, the number of those truth grounds of the proposition S, which are at the same time truth grounds of R, then we call the ratio T subscript RS colon T subscript R the measure of the probability which the proposition R gives to the proposition S. 5.151. Suppose in a schema like that above in number 5.101, T subscript R is the number of the capital T's in the proposition R, T subscript RS, the number of those capital T's in the proposition S, which stand in the same columns as capital T's of the proposition R, then the proposition R gives to the proposition S the probability T subscript RS colon T subscript R. 5.1511. There is no special object peculiar to probability propositions. 5.152. Propositions which have no truth arguments in common with one another we call independent. Two elementary propositions give to one another the probability 1/2. If P follows from Q, the proposition Q gives to the proposition P the probability 1. The certainty of logical conclusion is a limiting case of probability. Application to tautology and contradiction. 5.153. A proposition is in itself neither probable nor improbable. An event occurs or does not occur. There is no middle course. 5.154. In an urn there are equal numbers of white and black balls, and no others. I draw one ball after another and put them back in the urn. Then I can determine by the experiment that the numbers of the black and white balls which are drawn approximate as the drawing continues. So this is not a mathematical fact. If then, I say, it is equally probable that I should draw a white and a black ball, this means, all the circumstances known to me, including the natural laws hypothetically assumed, give to the occurrence of the one event no more probability than to the occurrence of the other. That is, they give, as can easily be understood from the above explanations, to each the probability 1/2. What I can verify by the experiment is that the occurrence of the two events is independent of the circumstances, with which I have no closer acquaintance. 5.155. The unit of the probability proposition is the circumstances with which I am not further acquainted give to the occurrence of a definite event such and such a degree of probability. 5.156. Probability is a generalization. It involves a general description of a propositional form. Only in default of certainty do we need probability. If we are not completely acquainted with a fact, but know something about its form, (a proposition can, indeed, be an incomplete picture of a certain state of affairs, but it is always a complete picture), the probability proposition is, as it were, an extract from other propositions. 5.2. The structures of propositions stand to one another in internal relations. 5.21. We can bring out these internal relations in our manner of expression, by presenting a proposition as the result of an operation which produces it from other propositions, the bases of the operation. 5.22. The operation is the expression of a relation between the structures of its result and its bases. 5.23. The operation is that which must happen to a proposition in order to make another out of it. 5.231. And that will naturally depend on their formal properties, on the internal similarity of their forms. 5.232. The internal relation which orders a series is equivalent to the operation by which one term arises from another. 5.233. The first place in which an operation can occur is where a proposition arises from another in a logically significant way, in essence, where the logical construction of the proposition begins. 5.234. The truth functions of elementary propositions are results of operations which have the elementary propositions as bases. I call these operations truth operations. 5.2341. The sense of a truth function of P is a function of the sense of P. Denial, logical addition, logical multiplication, etc., are operations. Denial reverses the sense of a proposition. 5.24. An operation shows itself in a variable. It shows how we can proceed from one form of proposition to another. It gives expression to the difference between the forms, and that which is common to the bases and the result of an operation is the bases themselves. 5.241. The operation does not characterize a form, but only the difference between forms. 5.242. The same operation which makes Q from P makes R from Q, and so on. This can only be expressed by the fact that P, Q, R, etc. are variables which give general expression to certain formal relations. 5.25. The occurrence of an operation does not characterize the sense of a proposition, for an operation does not assert anything, only its result does, and this depends on the bases of the operation. Operation and function must not be confused with one another. 5.251. A function cannot be its own argument, but the result of an operation can be its own basis. 5.252. Only in this way is the progress from term to term in a formal series possible, from type to type in the hierarchy of Russell and Whitehead. Russell and Whitehead have not admitted the possibility of this progress, but have made use of it all the same. 5.2521. The repeated application of an operation to its own result I call its successive application. Capital O prime, capital O prime, capital O prime, A, close quote, is the result of the threefold successive application of quote, capital O prime, close quote, to quotes A, close bracket. In a similar sense, I speak of the successive application of several operations to a number of propositions. 5.2522. The general term of the formal series A, capital O prime A, capital O prime, capital O prime A, I write thus, quote, square bracket A, x, capital O prime x, close square bracket, close quote. This expression in brackets is a variable. The first term of the expression is the beginning of the formal series, the second the form of an arbitrary term x of the series, and the third the form of that term of the series which immediately follows x. 5.2523. The concept of the successive application of an operation is equivalent to the concept quote, and so on, close quote. 5.253. One operation can reverse the effect of another. Operations can cancel one another. 5.254. Operations can vanish. Bracket, for example, denial in quote, not symbol, p, close quote, end symbol, not symbol, p, equals p, close bracket. 5.3. All propositions are results of truth operations on the elementary propositions. The truth operation is the way in which a truth function arises from elementary propositions. According to the nature of truth operations, in the same way as out of elementary propositions arise their truth functions, from truth functions arise a new one. Every truth operation creates from truth functions of elementary propositions another truth function of elementary propositions, in essence a proposition. The result of every truth operation on the results of truth operations on elementary propositions is also the result of one truth operation on elementary propositions. Every proposition is the result of truth operations on elementary propositions. 5.31. The schemata number 4.31 are also significant if quotes P, quotes Q, quotes R, etc. are not elementary propositions, and it is easy to see that the propositional sign in number 4.42 expresses one truth function of elementary propositions even when quotes P and quotes Q are truth functions of elementary propositions. 5.32. All truth functions are results of the successive application of a finite number of truth operations to elementary propositions. 5.4. Here it becomes clear that there are no such things as quote, logical objects, close quote, or quote, logical constants, close quote, bracket, in the sense of Frege and Russell, close bracket. 5.41. For all those results of truth operations on truth functions are identical, which are one and the same truth function of elementary propositions. 5.42. That or symbol, implies symbol, etc. are not relations in the sense of right and left, etc. is obvious. The possibility of crosswise definition of the logical quote, primitive signs, close quote, of Frege and Russell shows by itself that these are not primitive signs, and that they signify no relations, and it is obvious that the quotes, implies symbol, which we define by means of quotes, not symbol, and quotes, or symbol, is identical with that by which we define quotes, or symbol with the help of quotes, not symbol, and that this quotes, or symbol is the same as the first, and so on. 5.43. That from a fact P an infinite number of others should follow, namely, not symbol P, not symbol P, etc., is indeed hardly to be believed, and it is no less wonderful that the infinite number of propositions of logic (of mathematics) should follow from half a dozen "primitive propositions." But the propositions of logic say the same thing, that is, nothing. 5.44. Truth functions are not material functions. If, for example, an affirmation can be produced by repeated denial, is the denial in any sense contained in the affirmation? Does not symbol P, deny not symbol P, or does it affirm P, or both? The proposition not symbol P, does not treat of denial as an object, but the possibility of denial is already prejudged in affirmation. And if there was an object called not symbol, then not symbol P would have to say something other than P, for the one proposition would then treat of not symbol, the other would not. 5.441. This disappearance of the apparent logical constants also occurs if not symbol there exists symbol x and symbol not symbol f(x) says the same as x and symbol f(x), or there exists symbol x and symbol f(x) and symbol x equals a, the same as f a. 5.442. If a proposition is given to us, then the results of all truth operations which have it as their basis are given with it. 5.45. If there are logical primitive signs, a correct logic must make clear their position relative to one another and justify their existence. The construction of logic out of its primitive signs must become clear. 5.451. If logic has primitive ideas, these must be independent of one another. If a primitive idea is introduced, it must be introduced in all contexts in which it occurs at all. One cannot, therefore, introduce it for one context and then again for another. For example, if denial is introduced, we must understand it in propositions of the form not symbol P, just as in propositions like not symbol P or symbol Q, there exists symbol x and symbol not symbol f(x), and others. We may not first introduce it for one class of cases, and then for another, for it would then remain doubtful whether its meaning in the two cases was the same, and there would be no reason to use the same way of symbolizing in the two cases. In short, what Frege Grundgesetze der Arithmetik has said about the introduction of signs by definitions holds, mutatis mutandis, for the introduction of primitive signs also. 5.452. The introduction of a new expedient in the symbolism of logic must always be an event full of consequences. No new symbol may be introduced in logic in brackets or in the margin, with, so to speak, an entirely innocent face. Thus in the Principia Mathematica of Russell and Whitehead, there occur definitions and primitive propositions in words. Why suddenly words here? This would need a justification. There was none and can be none, for the process is actually not allowed. But If the introduction of a new expedient has proved necessary in one place, we must immediately ask, where is this expedient always to be used? Its position in logic must be made clear. 5.453. All numbers in logic must be capable of justification. Or rather, it must become plain that there are no numbers in logic. There are no preeminent numbers. 5.454. In logic, there is no side-by-side. There can be no classification. In logic, there cannot be a more general and a more special. 5.4541. The solution of logical problems must be neat, for they set the standard of neatness. Men have always thought that there must be a sphere of questions whose answers, a priori, are symmetrical and united into a closed regular structure, a sphere in which the proposition simplex sigillum veri is valid. 5.46. When we have rightly introduced the logical signs, the sense of all their combinations has been already introduced with them. Therefore, not only P or symbol Q, but also not symbol bracket P or symbol not symbol Q, close bracket, close quote, etc., etc. We should then already have introduced the effect of all possible combinations of brackets. And it would then have become clear that the proper general primitive signs are not P or symbol Q, bracket, there exists symbol X, close bracket, and symbol F, X, close quote, etc., but the most general form of their combinations. 5.461. The apparently unimportant fact that the apparent relations like or symbol and implies symbol need brackets, unlike real relations, is of great importance. The use of brackets with these apparent primitive signs shows that these are not the real primitive signs, and nobody of course would believe that the brackets have meaning by themselves. 5.4611. Logical operation signs are punctuations. 5.47. It is clear that everything which can be said beforehand about the form of all propositions at all can be said on one occasion. For all logical operations are already contained in the elementary proposition. For fa, says the same as bracket, there exists symbol x, close bracket, and symbol fx, and symbol x equals a, close quote. Where there is a composition, there is argument and function, and where these are, all logical constants already are. One could say, the one logical constant is that which all propositions, according to their nature, have in common with one another. That, however, is the general form of proposition. 5.471. The general form of proposition is the essence of proposition. 5.4711. To give the essence of proposition means to give the essence of all description, therefore the essence of the world. 5.472. The description of the most general propositional form is the description of the one and only general primitive sign in logic. 5.473. Logic must take care of itself. A possible sign must also be able to signify. Everything which is possible in logic is also permitted. Bracket, Socrates is identical, means nothing because there is no property which is called identical. The proposition is senseless because we have not made some arbitrary determination, not because the symbol is itself unpermissible. In a certain sense, we cannot make mistakes in logic. 5.4731. Self-evidence, of which Russell has said so much, can only be discarded in logic by language itself preventing every logical mistake. That logic is a priori consists in the fact that we cannot think illogically. 5.4732. We cannot give a sign the wrong sense. 5.47321. Occam's razor is, of course, not an arbitrary rule, nor one justified by its practical success. It simply says that unnecessary elements in a symbolism mean nothing. Signs which serve one purpose are logically equivalent. Signs which serve no purpose are logically meaningless. 5.4733. Frege says, every legitimately constructed proposition must have a sense. And I say, every possible proposition is legitimately constructed, and if it has no sense, this can only be because we have given no meaning to some of its constituent parts. Bracket, even if we believe that we have done so. Close bracket. Thus, quote, Socrates is identical, close quote, says nothing, because we have given no meaning to the word, quotes, identical, as adjective. For when it occurs as the sign of equality, it symbolizes in an entirely different way. The symbolizing relation is another. Therefore, the symbol is in the two cases entirely different. The two symbols have the sign in common with one another only by accident. 5.474. The number of necessary fundamental operations depends only on our notation. 5.475. It is only a question of constructing a system of signs of a definite number of dimensions of a definite mathematical multiplicity. 5.476. It is clear that we are not concerned here with the number of primitive ideas which must be signified, but with the expression of a rule. 5.5. Every truth function is a result of the successive application of the operation. Bracket, dash, 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 capital T, close bracket, bracket, xi, comma, dot, 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 close bracket, to elementary propositions. This operation denies all the propositions in the right-hand bracket, and I call it the negation of these propositions. 5.501. An expression in brackets whose terms are propositions I indicate, if the order of the terms in the brackets is indifferent, by a sign of the form, quotes, bracket, line over xi, close bracket, close quote. Quotes, xi is a variable whose values are the terms of the expression in brackets, and the line over the variable indicates that it stands for all its values in the bracket. Bracket. Thus, if xi has the three values, capital P, capital Q, capital R, then bracket, line over xi, close bracket, equals, bracket, capital P, comma, capital Q, comma, capital R, close bracket. The values of the variables must be determined. The determination is the description of the propositions which the variable stands for. How the description of the terms of the expression in brackets takes place is unessential. We may distinguish three kinds of description. 1. Direct enumeration. In this case, we can place simply its constant values instead of the variable. 2. Giving a function f(x), whose values for all values of x are the propositions to be described. 3. Giving a formal law, according to which those propositions are constructed. In this case, the terms of the expression in brackets are all the terms of a formal series. End of section 3. Recording by Jeffrey Edwards.